Hi colleagues! Today I would like to discuss with you next interesting topic regarding Hibernate. I called it Beyond Hibernate's Overhead. Let's start. Okay, let us answer the question, why Hibernate might have the overhead. There are a lot of built-in features which Hibernate has. And each of these features has its own purposes. For example, first level cache. Data in Hibernate can be cached in two levels, first level cache and second level cache. Second level cache is possible to disable it, and first level cache, it's in general case, it's impossible to disable it. And before Hibernate would flush the data to database, all changes are being collected on first level cache. So, periodical flushing changes to database and first level cache itself bring overhead when we are using a Hibernate. Also, for example, dirty check mechanism also brings an overhead when we are using Hibernate. Dirty checks, it's a mechanism which make it possible to save only those entities which are really were under the change. I mean, Hibernate is going to save only those entities which were really changed during program. That's why it calls dirty check. Hibernate checks entities if they are dirty. It means dirty means it was changed. It also requires some processing time. It also brings some overhead when we are using Hibernate. The same words it's possible to say about right behind mechanism, entity lifecycle management, different Hibernate's interceptors, and their customization. All features which I have discussed here, I said that they bring overhead. But it doesn't mean that they are bad. They made for good. They made for optimization. And in 95 or 99% of using Hibernate, these features solve the problem for which they were designed. But there are also the cases when we cannot disregard this overhead which these features bring to our program. That's why here I would like to discuss solutions for that cases which we can implement and how we can implement. Let us take a look. But before we start a discussion regarding different approaches to fight with overhead of Hibernate, I would like to highlight some stuff. This stuff is about Hibernate Entity Lifecycle Management and Spring Framework. Some time ago, Open Session in View feature was introduced in Spring. What does it mean? It means that Spring opens a new Hibernate session at the beginning of the request. Under request here, we understand the request to database. Every time the application needs a session, it will reuse the already existing one. At the end of the request, the same interceptor closes that session. Please keep in mind that this feature, I mean open session in view, can cause subtle performance in production, and these issues are very hard to find. This feature is turned on by default. From the experience, it's better to make it disabled by setting the property spring.jpa.openInView equal to false. Okay, and now I would like to discuss stateless session of Hibernate. There are two types of Hibernate session. Let's say usual session, which is used by default, and stateless session. Stateless session of Hibernate doesn't have an associated persistent context. There is no first level cache, no entity lifecycle management, no all those features which bring overhead. And a little bit later, we will jump to code and take a look how we can implement the stateless session. But before it, I would like to stress the following statement, of which I took from my experience. If you have your program or your microservice which is written by using Hibernate, and you have only small amount of cases in your coding that bring overhead, and this overhead costs a lot for you, then it's okay to use stateless session. But if your program is going to be written by using Hibernate and you will use stateless session everywhere in your program, probably you're doing something wrong and you need to rethink about design of your program or microservice. So now it's time to take a look on the real code. And first I would like to make some code review where I would like to describe which artifact do we have and what we are going to look at. First of all, I have introduced a new entity. I called it many rows entity. The purpose of this entity is to just to store 500,000 rows. Also, I introduced a repository for this entity. I called it many rows entity repository as usual. It's an extension of JPA repository. And also I introduce here some method which I would describe in details a little bit later in this video. Okay, as I said, many rows entity repository is an interface which extends JPA repository, and Spring would generate for us actual repository. And also I wanted to add some custom method to this repository. And to make it possible, I have to implement approach or object so-called composable repository. What does it mean? To implement composable repository, I need to create new interface, and I called it customized many rows repository, where I have put two methods. One method, name of it is find all using stateless session, and another is find all using stream. And I also created an implementation of this interface. The implementation of this interface is many rows entity repository impl. And here we have two implementation of these two abstract methods from the interface. One implementation for find all using stateless session, and another is for find all using stream. What we have here, I will describe in details a little bit later. And now I'm going to proceed with my code review. Okay, and now I would like to show you that I have added new flyaway scripts. Here I am creating just many rows table, and the script is pretty simple. And to check how stateless session in Hibernate works, I introduced new test class. I call this test class beyond overhead showcase test. And here I have three test methods, one method per, let's say, per test case. And this method, check find all using stateless session, it's exactly what we are going to consider very soon. And also here I introduce a new flyaway script for my test. Here I just fill in my many rows table with 500,000 rows where I just concatenate word name with counter in the loop. Now let us take a look on a test case which is devoted to using stateless session. Here we have a test method with name check find all using stateless session. And what I have here I just call a method of this many rows entity repository. As I already said, the name of this method is find all using stateless session, where I actually use the stateless session. I receive some list of many rows entity from this method, and what I'm doing here, I just make an assertion that size of this collection is equal to 500,000. Also, I have injected many rows entity repository to my test class. What I have in my in my composable repository in this method and find all using stateless session. Here in this class I injected entity manager. In this row I am receiving session factory, and here in try with resources I am open stateless session. It's a standard method of session factory, and here I just create a query where I am selecting all entries from many rows entity, and here I am returning many rows entity list. Now let us run our test method and see which actual SQL query Hibernate is going to generate. I am going to run this test method without debug because there is no need for that. Let us run it. And during this run, test containers is going to be up, and flyaway script is going to be deployed on this Postgres entity, Postgres instance. It requires some time. And in console, we can see that our stateless session works. Hibernate generate one SQL query for our many rows entity, for our many rows table, and we can see it here, and it works. As a result, what I am going to say is that, as I already said, you can use stateless session when you would like to avoid any additional works of Hibernate. Here we have a situation where approach how Hibernate operates almost equal to calling pure JDBC method.